Here's a little bit of help on your homework, Solving Trig Equations Part 3 worksheet. So let's do number 1. So first we're going to divide both sides by square root 3, and we have tangent theta equals 1 over square root 3. Don't worry about rationalizing that. It's actually going to be more helpful if we leave it like that. And now we're going to take the inverse tangent of both sides. So theta is the inverse tangent of 1 over square root 3. So that's a positive. Tangent is positive in quadrants 1 and 3. So let's draw a little picture. So we have 1 on the opposite, square root 3 on the adjacent. Oops. There we go. So what angle are we looking at here? We would be looking at a 30-degree angle, 30-degree reference angle. So our two answers are 30 degrees and then 210 degrees. So if we want to start by writing those answers in degrees, we have theta equals 30 degrees. And remember from the lesson, we're going with all the answers, infinitely many answers. So everything that's coterminal with 30 degrees would be 30 degrees plus 360 degrees times n, where n is an integer. Now you don't have to write n as any integer every time you do a problem. We'll just understand that that's what we mean when we put n. And then the other answer is 210 degrees plus 360n. Now here's the thing. Because we have answers in opposite quadrants, and those answers are half a circle apart, you could consolidate these answers together. So you could list the first answer, 30 degrees. You could go 180 degrees to get to the next answer. You could go 180 degrees to get to the next answer, and so on. So what we're going to do is rewrite this as 30 degrees plus 180 times n. And now we're going to answer in radians. So our answer is pi over 6 plus pi times n. Now let's do number 2. Okay, it's already factored. We're going to set each factor equal to 0 and solve each equation. Okay, so for the first one, let's add square root 3 to both sides and divide by 2. And then take the inverse sign. Okay, so that's positive, and sign is positive in quadrants 1 and 2. We would have square root 3 on the opposite and 2 on the hypotenuse. So the angle would be 60. So our answers are 60 and 120. Okay, so we have 60 degrees plus 360n. And we have 120 degrees plus 360n. So changing those into radians, we have pi over 3 plus 2 pi n. And we have 2 pi over 3 plus 2 pi n. Now let's do the other equation. So we're going to subtract 1 from both sides and divide by 2. And then take the inverse cosine. And cosine is negative in quadrants 2 and 3. So in quadrant 2, we'd have the negative 1 on the adjacent, the 2 on the hypotenuse. So that again is a 60-degree reference angle. So we have 120, and we have 240. Now we already gave our answer for 120 a moment ago, so we really don't have to give it twice when we make our final list of answers. We do need to add in the 240 plus 360n, and let's convert that to radians. So that would be 4 pi over 3 plus 2 pi n. Okay, now here's the thing. The quadrant 1 answer and the quadrant 3 answer we got the quadrant 3 answer from part 2, we got the quadrant 1 answer from part 1, but those are 180 degrees apart. So we can consolidate those two answers together. And let's write that as pi over 3 plus pi times n, and then we have the other one, 2 pi over 3 plus 2 pi times n. Okay, moving on to number 3. So remember in our last lesson when we did some equations where we did a trigonometric substitution? So we used Pythagorean identity. The most commonly used one is cosine squared theta plus sine squared theta equals 1. So if you want to isolate cosine squared theta, you get cosine squared theta equals 1 minus sine squared theta. And you can substitute that into the equation for cosine squared theta. So we have 1 minus sine squared theta minus sine squared theta equals 0. Okay, so we have 1 minus 2 sine squared theta equals 0. We could add 2 sine squared theta to both sides and divide by 2. And then we would take the square root of both sides, and that, don't forget about plus or minus. And when you see square root of 1/2, you can do square root of the top and square root of the bottom. Now we know that that will rationalize to give us square root 2 over 2, and we don't have to write it rationalized. It might be more convenient to work with like this. So what angles have a sine value of square root 2 over 2? We put the 1 on the opposite and the square root 2 on the hypotenuse, and we realize that that is 45 degrees, and we're in every quadrant because we have 2 positive quadrants and we have 2 negative quadrants. So we have all the 45s. So theta is 45 degrees plus 360 n. (135 degrees plus 360 n), 225 degrees plus 360 n, and 315 degrees plus 360 n. But those are all just 90 degrees apart, so let's write it as 45 degrees plus 90 times n. And then our radian answer is going to be pi over 4 plus pi over 2 times n. Okay, number 4. So this one is a quadratic in disguise. So let's get everything over to one side and then see if it factors. So this factors into tangent x plus 1 times tangent x plus 1. So we have tangent x plus 1 quantity squared. We can just square root, and when we square root 0, we get 0. So if tangent x plus 1 equals 0, subtract 1 from both sides, tangent x equals -1. Take the inverse tangent. X is the inverse tangent of -1. So where's tangent negative? Tangent's negative in quadrant 2 and quadrant 4, and it would be a 45-degree angle. So we have 135, and we have 315. So we have 135 plus 360n and 315 plus 360n. Now these are just 180 apart, so we can consolidate it into 135 plus 180n, and that will account for all of them. And then we'll change to radians, and we get 3 pi over 4 plus pi times n. There we go.